Hey everybody, all right, this is Mr. Pickett. I love that, don't you guys? Okay, all right. What we're going to be doing is we're going to go through the lab a little bit, how I would attack it. Again, it doesn't mean it's the right way to do it. It just means it's the way that I would go after it. And what we're trying to solve in the lab is how does mass affect potential and kinetic energy? So number one, I already know that mass and kinetic energy have an effect on, mass has an effect on potential and kinetic energy. So I'm just proving that it does and how it does. So one thing that I'm really thinking about in my head is that I have to do lots of trials, probably at least 5, and the thing that I'm changing is the mass that I'm using. And I think as I watch some of the kids attack this a little bit, they didn't change any mass whatsoever. They were so focused on this wonderful photo gate thing right here, and we had this the entire time, that we didn't actually attack the lab, where I constantly changed one thing over and over again to see a result. That was the purpose of this activity, was for you to manipulate or change mass and then to see how it affects kinetic and potential energy. So I actually took these things out and I put them on the corner of my room, hoping that some student would go, I should use this mass, hang it from some sort of a pendulum, and then let it swing, and then do it again, except use a different mass this time. And then do it again. And then eventually use a very large mass, and then do it again, and see if it has any effect on potential or kinetic energy. Now, I already know that if I keep on raising the amount of mass that I have, and I keep getting it to the same height, so up to here, class, is that going to affect the potential energy it has? Mm-hmm. All of us know that. And so I'm keeping the height the same. I'm going to let it drop. I already know my amount of potential energy that I'm going to end up having is going to be higher. But I just need to record that information in some way, shape, or form. That's all. So I would have done 3 to 5 trials. I probably would have started with this little dinky thing right here. This I think it's a 10-gram mass, and I have to convert that to kilograms. I would have hooked it onto my little system right here. And honestly, I don't really need to actually hook it on here if I just calculate the height here. So I take the 10 grams, convert it to kilograms, which would be a 0.01 kilograms, multiply it by gravity, 10, and multiply it by its height in meters. I already got its potential energy. So I could do that for 3 to 5 masses. That's what I would do. So the main part of my lab that I have to calculate is how fast is this thing going when it's at its highest kinetic energy. And I know that the highest kinetic energy is right down here in the center. So figuring out how fast this thing's going to go right at this point in time, that's what I need to, I guess, use some sort of a piece of equipment, which would be this photo gate, to calculate. Now, do I need the photo gate? Absolutely not. Why don't I need the photo gate? Okay, let's conceptually look at this. If I take this mass right here, which I'm having you guys disregard that there's a ball attached to this, it doesn't exist. Just imagine it's not there. I just have this 0.01 kilogram mass. This thing is moving at 0 meters per second right now, where it's at its highest potential for energy. Is everybody with me? It's moving absolutely nothing. Okay, where it's going to be moving its fastest at is right here. So how quickly is it going to get there, and how do we calculate that? Well, what we need to kind of figure out is its average velocity. And what I could do is I could take a stopwatch, and this is low tech. This is very low tech. I could take a stopwatch, and I could calculate the time it takes to go from here to here. I could calculate that time. I could also calculate the distance from here to here. And what that would give me is an average velocity. Now that average velocity is basically saying that it's going to go that velocity from up here to down here. I hope all of us know that it is going 0 meters per second here, and it's going to constantly increase its velocity until it gets to this point in time right here. That means the velocity is not constant. So if I calculate an average velocity, it's not a right velocity. It's saying, okay, probably right here. So the midpoint between the very bottom and the very top, that's probably how fast it's going right here. So how quickly am I going at this point in time? Multiply that average velocity by 2. It's kind of like if I go in and I average a 50% out of 2 exams. If I know that my initial exam was 0, how can I get to a 50% average? I multiply 50 by 2 because there's 2 things that are there. So if I calculate average velocity by timing, the time it takes to go from here to here, which that's really hard to do, dividing it by the distance between those 2 points. That would give me average velocity, which would be this velocity about at this point in time. If I multiplied that by 2, that would give me my high velocity, which would be right here. If you don't have access to a photo gate, you can certainly do that. It's not the best way to do it, but if you don't have access to a photo gate, that's what you do. I do not want you to be photo gate hogs. You don't need this the entire time. This could be set up on somebody's computer, and when you're ready to test, which the test takes about 10 seconds to get the piece of data, you can sit there and do that and go back to your group and go through the calculations. To sit with the photo gate at your group is basically you being a hog and you holding on to this piece of technology thinking that this is what the lab's about. Okay. After I get all that kinetic energy, at least after I calculate the velocity, I still got to plug stuff in. So for every one of my masses, I find the velocity. For every one of the masses, I find velocity. I find velocity. Then I've got to plug that stuff into my equation, and then I have to show how the amount of mass affected the amount of potential energy and the amount of kinetic energy. For me to show that as a piece of evidence, I need to collect data. I need to have a data table. I probably need to have a graph. Those things are how you show that you have evidence. Okay. Have a great day, everybody. It's Monday. I'm wearing purple.